ya que vamos a retomar la sesión, en esta última parte la idea es escuchar la charla del profesor Sandrini, que ahora os voy a presentar y os voy a contextualizar un poco, pero la idea básicamente es la de que en el contexto de su charla, que va a focalizar sobre la memoria episódica, no por casualidad yo he evitado hablar. He tenido que hablar un poco de memoria esta mañana, pero he evitado hacerlo precisamente porque Marco iba a hablar de forma extendida sobre la memoria episódica. Y la idea es escucharle y luego tener tantos minutos, hasta cierto punto como sea posible, para un debate respecto al tema de la jornada, ¿no? Y poder responder a la pregunta que da título, ¿no? De si realmente se puede mejorar la actividad cerebral y si eso tiene implicaciones a qué niveles. Bueno, pues os presento al profesor Marco Sandrini. Para mí, yo sé que estas cosas se suelen decir, pero para mí es especialmente interesante y me produce un enorme orgullo presentarle, porque yo ya tengo una edad en la que puede pasar que uno se reencuentre con gente mucho tiempo después, y al profesor Sandrini lo conocí cuando ninguno de los dos éramos profesores. Hace como 18 años en una escuela de verano, precisamente en Granada, en una escuela de verano organizada por la Sociedad Europea de Psicología Cognitiva sobre memoria. Y bueno, ahí creo que no hablamos mucho de neuromodulación, hablábamos de otras cosas, pero creo que de neuromodulación no éramos muy jóvenes. Pero ahora, pues, bueno, lo he reencontrado en los papers que he leído de él, que son muchos, porque efectivamente él trabaja, como vais a ver, fundamentalmente en relación con la memoria episódica. Él se doctoró en la Universidad de Verona, dirigido por el profesor Carlo Mignusi, que es, para mi gusto, una eminencia en relación con la actividad cerebral y la neuromodulación, y ha hecho estancias de investigación postdoctorales en la Universidad de Trento y también en el Instituto Nacional de Salud con Leonardo Cohen en Estados Unidos. Desde hace 6 años o 7 años es profesor asociado en la Universidad de Roehampton en Londres, y como os decía, la mayor parte de su trabajo, no solo, pero la mayor parte de su trabajo se ha focalizado en el uso de la neuromodulación, ya sea con TMS o con TDCS, en el intento de mejorar la formación de memorias episódicas, sobre todo en envejecimiento. Supongo que parte de su charla se focalizará en ese asunto. Y para terminar, yo destacaría del profesor Sandrini algo que me parece muy interesante y que he dejado caer en mi charla, y es la necesidad de hacer buenos diseños de experimentales cuando, al menos en neurociencia cognitiva, queremos responder a preguntas también en relación con la neuromodulación. Él tiene formación en psicología experimental y en neurociencia, y creo que se le notan ambas cosas, y eso hace que, pues, algunos de sus procedimientos experimentales sean especialmente interesantes, muy elegantes en muchos casos y muy sugerentes a muchos niveles distintos. De manera que os presento al profesor Sandrini y creo que vamos a disfrutar de su charla. Cuando quieras.
Okay. Thank you, Carlos and Fernando, for inviting me at this meeting, at this conference. And so I'm going to talk about mainly my topic of research, that is neuromodulation of episodic memory. I was involved also in some modulation of response inhibition, some implication for TBI, but this is the main area of interest. So it started more or less 10 years ago during my postdoc at NIH. So I had this idea for a long time. So my research goals, in particular, was involving to try to develop what we call an effective intervention, TDCS mainly, to reduce memory decline in population at risk of developing Alzheimer. Because for me, when you have Alzheimer, it's too late. In particular, when you want to do some non-invasive brain stimulation, I think it's too late. You can play a little bit earlier, or very, very mild Alzheimer. This is my view, okay? So what I'm going to talk about today, I'm going to talk a little bit about what is memory formation, consolidation, and memory modification through reconsolidation. I'm going to show some data that show the effect of lateral prefrontal cortex and posterior parietal cortex in episodic memory reconsolidation. I'm going to show some episodic memory enhancement induced by TDCS over prefrontal cortex in physiological and pathological aging. And recently I'm working more in to determine some inter-individual factor that can modulate the response of this intervention. So some kind of marker or biomarker, what we call. So let's start with this new model that I proposed some years ago with Leonardo Cohen in the United States. So as we know, new encoding memory are unstable initially, okay? So unstable means fragile, so vulnerable to interference. But as time passes, memories stabilize or consolidate, okay? And so to become a little bit stable. So after consolidation, memory becomes stable. So according to the consolidation view, once memories are consolidated, memories cannot be modified, okay? But accumulated evidence has shown that this is not the case, okay? Consolidated memories can re-enter unstable state when we reactivate the memory. So reactivate the memory during retrieval or by a reminder cue. Okay? So the memory is unstable again, and then we can reconsolidate or consolidate again to become stable again. Okay? But importantly, during this reconsolidation window that is about 1 hour, we can modify existing memories. And this has huge clinical implication because we can suppress or decrease some maladaptive memory, for instance, in case of PTSD or drug addiction and so on. Or, in my view, we can strengthen, enhance some adaptive memory, such as in the case of episodic memories. And there are different ways to do this. We can do through behavioral means. We can use stressor events. We can use pharmacological agents. For instance, propranolol has been used to try to decrease maladaptive memory. Or we can use non-invasive brain stimulation, okay, to try to modify the memory, okay? So as I repeat, so consolidation refers to the processes that stabilize memories after encoding or initial acquisition, transforming them into long-term memory. You know that there are two types of consolidation, the cell level or system level, based on the time. Instead, reconsolidation refers to the process that restabilizes the consolidated memory after reactivation, okay? It's quite clear so far? So, this is going to talk a little bit about the neurosubstrate of episodic memory. So episodic memory refers to the memories of events or episodes. For instance, what you ate at the restaurant yesterday night, or what did you do for breakfast, or did you do this morning, and so far. And the area involved, we know from HM that it was the most patient study in the history of neuroscience, that the medial temporal lobe, in particular the hippocampus, is very important, particularly for memory, also for consolidation, but we know also from neuroimaging and some non-invasive brain stimulation, but also the prefrontal cortex, both dorsolateral and ventrolateral, but also the posterior parietal cortex are important for this type of memory. And also the functional interaction between these areas are important, from the cortical areas to the subcortical, like the medial temporal lobe, okay? So yeah, a brief overview, just to know that change in what we call behavioral performance in a cognitive task, so that can be also interference or facilitation effect, can be used to establish mainly a cause-effect link. between a cortical region and a cognitive function. This is more true for TMS, that is more focused, more specific, but also is true for non-invasive based stimulation, because we are going to change behavioral performance, improving or decreasing. But also because TCS and also repetitive TMS can induce long-lasting effects, mainly due to LDP or LTP mechanism, these techniques are also used as adjuvant strategies for neurological or psychiatric deficit, okay? So, my first question 10 years ago was try to understand more the role of dorsolateral prefrontal cortex. He has some role in strengthening episodic memory through reconsolidation. Study started to show that we can enhance memory through reconsolidation, but I wanted to know more in terms of neural substrate, okay? So I did this classical reconsolidation experiment that involved at least 3 sessions. So in a between subject design, in the first day they have to learn a list of 20 words, okay, participant, and they have to reach at least a criteria of 17 out of 20. And they have 4 learning trials. So you're going to show this word, they try to repeat, you're going to show again, and so on. Then they come back after 24 hours. We know the importance of sleep for memory consolidation also. And then what happened on day 2? We try to reactivate the memory, the existing memory. And we put the subject in the same experimental room of day 1. There are some studies that have shown that if the participants are in the same experimental room, there is an automatic reactivation of the memory, okay? And so we use this procedure, and then we apply TMS, rTMS over the right prefrontal cortex, a brain region that is involved in memory retrieval, okay? We apply instead also after reactivation on a control site. Vertex is the midline scalp location that is considered a neutral stimulation site. Under the vertex there is the representation of the leg, okay? And this good stimulation is better than sham, because sham TMS reproduce only the same sound of real TMS, but not the same somatosensory sensation. Instead, vertex reproduce also the real stimulation, okay? So it's a good control condition. And then we had another group that the memory was not reactivated. So we changed the room from day 1 to day 2. We use a different room, but we stimulate always the prefrontal cortex, the right prefrontal cortex. So we have 2 control conditions. One, we wanted to see the site if it was specific to the prefrontal cortex, and one we want to see if it was specific to the reactivation or not, okay? Then on day 3, they have to do a free recall. They come back, they have to recall as many words as possible, okay? And as you can see here, on the y-axis, there is the percentage of word correctly recalled, the dependent variable. The independent variable is the TMS group. And you can, as you can see, the prefrontal cortex reactivation group recall more words compared to the control groups. So we can conclude that compared to control groups, stimulation of right dorsolateral prefrontal cortex after memory reactivation strengthen, I say strengthen existing episodic memory because an effect was enhanced 24 hours later after the simulation. Simulation was done on day 2. And you can observe the effect on day 3, okay? But it's not over. So people always, when you send this article to some good journal, like was Current Biology, you have a lot of critics. So they ask us to do a control experiment. So we wanted to see if the effect was reconsolidation specific. Okay? Because consolidation requires many hours. Okay? Because it requires gene expression. No? It takes at least 3-4 hours at least. It should be concluded within 6 hours. So they ask us, you need to show that the effect is time dependent. So what it means, you need to show that when you do TMS and you test the memory immediately, there is no effect. But there is only effect if you allow the memory to reconsolidate. So what I did, I had the same experimenter, but only 2 sessions. Day 1, they learned the word, 20 words. On day 2, we use only 2 groups, vertex or prefrontal cortex after reactivation. And then we tested the memory 30 minutes after the TMS. We tested 30 minutes to allow the after effect of RTMS to wash out, because we didn't want to interfere with the retrieval process, okay? We tested the memory, there were no effect if we tested the memory immediately after, okay? So we can conclude that memory modification, in this case memory strengthening, didn't occur shortly after TMS, and so the effect of experiment 1 is time dependent, because you only observe the effect if you allow the memory trace to reconsolidate, okay? And this was, I think, a little bit a game changer for people, because I was showing for the first time that with a non-invasive brain stimulation, in particular with TMS, I was able to strengthen memory. When most of the study, they were using some intervention to try to decrease maladaptive memory. So I conclude that dorsolateral prefrontal cortex play a causal role in strengthening episodic memory through consolidation. Consider the role of hippocampus also in contextual reconsolidation. I think RTMS may have strengthened the functional connectivity between the prefrontal cortex and the hippocampus, and therefore enhancing recollection. But also this is what I wrote and what I tested in the next year. So non-invasive brain stimulation of prefrontal cortex during reconsolidation may serve to enhance this existing episodic memory in patients that have difficulties. And the first thing to try was what patient, but people told me also, you can test also older adults. Older adults has a decline in episodic memory, a physiological decline, but you can see if there is an effect on them before to move to patient, okay? You need to know, but this is quite important in terms of episodic memory decline. So episodic memory showed the largest age cognitive decline. So it's very affected by age. And the first step is what we call subjective memory impairment. So people that complain about their memory, but if they do some neuropsychological tests, they are normal, okay? There is a complaint. And then you can progress to MCI, so amnestic mild cognitive impairment, because MCI can be also multiple domain, can affect also more cognitive function. But in this case, MCI, they have subjective, but also objective memory decline. So if they do some neuropsychological tests, they fail in episodic memory tasks. But the difference between Alzheimer is that MCI, they preserve independence of functional ability. So they are able to go to the store, to prepare a meal, to do some activities. But Alzheimer are compromised. This is the main difference. And also it's important to know that many clinical trials in mild to moderate Alzheimer have shown mixed results. Most of them also fail. There is some drugs, as you know, probably anticholinesterase inhibitors that can reduce some symptoms, but it's not a treatment. Recently, there is a lot of news about this new drug that can decrease the amyloid plaque, aducanumab or lecanemab, but there's some issue. They have a lot of side effects. The effect is not great. So they have a lot of brain swelling, brain bleeding, and also aducanumab has been approved in the US, but not in Europe so far, okay? And also probably gonna happen the same for lecanemab, okay? So there is some potentially good news, but not so great. So it's important to develop also alternative treatment, okay? And also what is nice now in research is the idea of prevention, okay? You can do prevention, try to reduce the risk for healthy people to develop Alzheimer or to develop MCI, or you do secondary prevention. Try to delay the onset of MCI to Alzheimer, okay? Not all MCI develop Alzheimer, but they are at great risk of developing Alzheimer. And also this is probably true in all the countries. This was some data from Alzheimer UK that said that only an intervention delay the onset of dementia by 5 years would both reduce the number of cases by a third and alleviate the economic cost by 36%, only delaying the onset, okay? We are not talking about treating the disease. So the second question was try to apply this intervention, prefrontal cortex, through reconsolidation using TDCS instead of TMS, because TDCS has some advantages, better for some randomized clinical trial because they're quite good blinding, so people they don't know if they are in the real or the sham group. Also, experiment is quite good. Also has potential to be applied at home and so on. But so we have tried to test if it was the case for healthy older adults. Okay. So, but based on previous studies that my colleagues collected, they've shown that there is a kind of reduced asymmetry between young adults and healthy adults. In young adults, is more the right prefrontal involved in retrieval. In older adults, is less evident. It seems to be that less is more involved than right. So basically, it was the same design. They have to learn a list of 20 words on day 1. Day 2, they received TCS. The anode was applied over the left dorsolateral. The cathode over the contralateral supraorbital. You can see here a picture of the current flow. You can see that is not really focal. So be careful when people apply the anode over one area. I claim that this is the area involved. Is 2 electron montage, there is always a current flow. And sometimes seems to be that the maximum peak is between the 2 electrodes, okay? So recently, Alexandro Pitts in Minnesota did some modeling of this montage, and he showed that the maximum peak for this study is in the frontopolar, is not under the dorsolateral, okay? But anyway, the idea was try to improve, okay? So we apply real, so active or anodal is the real TCS, and sham. Sham is a kind of placebo, so you turn on the stimulator for 30 seconds, so the subject receives the same sensation, and then you turn off, okay? And subjects have difficulty to discriminate between real and sham, okay? And then we have 2 free recall tasks. One on day 3, but also we tested on day 30, 1 month, so the follow-up. As you can see here, we found an effect up to 1 month after 1 session of TCS, applied through reconsolidation, okay? And this effect was not influenced by the learning strategies, and number of word recall during day 1, and so on. So there was another question. So in order to develop an effective intervention, people can say, oh, you have done this through reconsolidation. Try to do the same during encoding, initial acquisition, because stimulation might enhance task-related plasticity. So the question was, what is the effect of TDCS applied over prefrontal cortex during encoding? So learn a list of words on day 1. At the same time, they receive stimulation. Another is the active stimulation compared to sham. We have this. Obviously, all the studies were double-blind. Okay, neither the experimenter nor the participant knows about the condition. Okay, so you avoid a lot of bias in analyzing the results. And we used the same montage of the previous study and tested the memory at the same time. We found an effect only at day 3. We didn't find an effect up to 1 month, day 30. So I said, let's continue to do TDCS during reconsolidation. And the next question was try to apply prefrontal cortex during reconsolidation in subjective memory impairment. Okay? In people that complain about their memory, okay? And these people seems to be at risk of developing Alzheimer. There is something already in the brain that is not perfect. But if you do some neuropsychological tests, probably they are not sensitive enough to detect something, okay? In particular, this is the inclusion-exclusion criteria. I want to emphasize that all the patients didn't have any mood or anxiety disorders, okay? Because people that are depressed or anxiety try to complain more about their memory. So we exclude all these patients. Say design, learn a list of words, TDCS over the prefrontal cortex and sham. We had day 3 and day 30 free recall, but we had also a recognition task, okay? We had a free recall, but also a recognition task where you need to say if the word was seen or new, okay? And here you can see we found an effect only on recognition, not on recall. An effect up to day 30. We found this effect, and this in line with evidence that shown that basically mainly older adults had difficulty with recollection, but they have quite preserved a sense of familiarity, okay? But one of the best news, I was talking to Carlos before, is that a group from David Barter Fats in Barcelona replicated my study with subjective memory impairment. Replicate exactly what we did, okay? And luckily, they found the same result. They found, because this is your concern that they don't replicate your data, but they found the same effect using an independent, also a large sample size compared to ours, up to 1 month, but also they collected some fMRI structure and resting state at the beginning to try to predict a little bit the TCS responsiveness. Because I'm going to show later that a lot of studies show a lot of variability. Some people respond, some people not. Why? We need to understand mainly more based on some marker or biomarkers, okay? And they found that structural preservation of temporal lobe regions and also the functional integrity of the default mode network, that seems to be important for episodic memory, predict the cognitive response to TCS. Okay? So at least this data has been replicated, but then we ask the next question. So does TCS overperform the cortex during reconsolidation, enhance memory in MCI? This was a little bit of pilot data, I have to say. We didn't get many participants. We have only around 9 per group. But anyway, we include participants that had the mini-mental score above 24, and they were pathological in some episodic memory tests, also the story recall, ray auditory, and so on. Okay? And we did the same. Day 1, learn a list of words, TCS apply on day 2, in the same room or in the same room, real or sham, and then test the memory day 3, day 30, free recall or recognition, okay? Identical studies. Here we didn't find an interaction group by time, sorry. We found only an effect of group. So I cannot say if the effect is at day 30 or day 3 or day 30, okay? It's an effect of group, okay? This is what we found. But anyway, we can say that at least TCS during consolidation enhanced delayed recall, okay? When it was tested day 3 or day 30. So then people start to ask me, well, what is the putative brain mechanism of this effect? Yeah, good question, I say. So this is some speculation. So I think that in agreement with also some former colleague Susan Yagi, we discussed quite a lot some data, but they have some data on the consolidation. We have many on reconsolidation. Facilitation or consolidation processes might be the mechanism acting during the hours or day after TCS. So you try to facilitate more the consolidation mechanism. And also it's important to know that not only sleep is important for memory consolidation, because there are also data that show that reactivation of the encoding memory, or what is called replay, in the subsequent waking state. So also the waking state is important. There is a nice review by Wensley, okay? They have done some study that they show that if you learn a little word and then you rest for 20 minutes, if you learn a little word and you play some video games, some interfering activity, your memory is better if you rest instead of intervening with some cognitive activity. So it seems to be that also some this waking state after the encoding is important for memory consolidation. And what I think is the mechanism that when we apply TCS during consolidation or reconsolidation, say here, this might boost neural reactivation and therefore enhance system level consolidation. This is quite a possible mechanism. This is only speculation. I don't have any direct evidence. This is one of the projects I'm more proud of that I've done in the last year. So in order to test also the optimal time of stimulation, apply encoding or consolidation, reconsolidation, that is important, the time of application. It's important to determine also where, prefrontal cortex, but people told me, why do you stimulate posterior parietal cortex? It's also an area important for memory, episodic memory. Because some studies have shown that the involvement in encoding, by particularly in memory retrieval, a lot of studies have shown that posterior parietal cortex is important. So I asked this question, if the posterior parietal cortex play a causal role in strengthening episodic memory through reconsolidation. But in order to do this study, I did something that in theory everybody should do, to do a register report, okay? So the register report is accepted in many journals. You have a good research question, you have a good methodology, you go through peer review before collecting the data. If the peer review is okay for you to collect the data based on the methodology research question, you start to collect the data and then you publish independent of what result you get, negative or positive, okay? You need to think that is not the result that make an article important, if the research question or the quality of the methodology, okay? So register report, basically is quite strict in stage 1 because you need to do a lot of power analysis to demonstrate what is the sample size, okay? Eliminate this publication bias and eliminate the selective reporting of the results, okay? Or also what we call p-hiking, okay? Reporting only look at the result and then you postulate the hypothesis. 90% of the people still does this, okay? You get the result, oh, what are the hypotheses now? No, the hypothesis should be first, and then you collect the data, and that's what you get, okay? But in this format, if phase 1 is approved, you're gonna publish the result anyway, okay? You're gonna publish the paper, okay? So basically for do this study, we had to collect 27 participants per group, okay? And each participant came for 3 sessions, okay? Because it's also important to have a good quality, so you need to have all the control procedure in place, okay? So we simulate using this list of words, learn 20 words on day 1. Day 2, same room of day 1, okay, reactivation. Prefrontal cortex, sorry, posterior parietal cortex. And then we use VU1 as a control. And as a control for reactivation, we have no reactivation, some different experimental room, but always parietal cortex simulation. We try to simulate we try to optimize a montage. Obviously, this can be criticized as the main limitation because was not so focal on the posterior parietal cortex. Probably was better, I have to say, to do TMS for this study. But anyway, and then we tested the memory on day 3. So basically, we didn't find anything. We didn't find a difference in the memory between groups. I say this because I want to emphasize one point. It's always important to have a good sample size. Sometimes it can be painful to test more participants, but this can make a quite difference. So my previous data shows something, but the sample size was quite limited, I have to say, okay? I'm honest. When I did with a large sample size, it's tough, okay? Because, I'm gonna say later, there is a lot of variability in the response of this non-invasive brain stimulation, so, okay? So, but obviously this can be also due to other stimulation parameters, the montage, the site of stimulation within the ventrolateral or dorsolateral posterior parietal cortex. So as I said, the effect in particular in aging, there is a lot of variability, heterogeneity in the response of this intervention. And this is the problem. So the same intervention doesn't have identical effects in all the subjects. So it can be beneficial for some people, but not for others. Why? We try to address this in a simple way. We reanalyze the data with healthy older participants when this time of stimulation was done during encoding and reconsolidation. We add the age, education level, encoding performance, TDCS group, and the timing of TDCS application. And also, do you know what is cognitive reserve? So cognitive reserve seems to be quite important in older adults, okay? Not only in older adults, but basically we measure cognitive reserve with a questionnaire. There are a lot of questionnaires also standardized now, available in different languages, but take into account not only the level of education, where people say, oh, level of education is a proxy of cognitive reserve. Not only. This takes into account the level of education, the training that you have done during your life, your working related activity, and also your leisure time. If you participate in social event, physical activity, take into account a lot of information. Okay? And based on Stern, cognitive reserve could be a protective factor in subjects at risk of cognitive decline. And cognitive reserve helps to optimize cognitive performance also if you have some brain changes, okay? Also, some studies support the notion that high level of cognitive reserve are associated with better cognitive performance, okay? And reduce the risk of developing dementia later in life. So it's a quite important factor to consider. So as I said, we reanalyzed our previous published paper, but use the same participant in terms of healthy older adults, but we use the same paradigm and stimulation parameters. So it was not we analyzed two studies with different stimulation parameters, because sometimes the difference can be also the stimulation parameter you use. But we use the same parameter, same stimulation montage, same intensity, same duration, okay? So this was identical. And we found, through multiple regression model, reveal an interaction effect of TDCS group and cognitive reserve total, but also cognitive reserve education, okay? Basically, we found what is called a crossover interaction. Because if you want to predict the effect of TDCS-induced memory enhancement, you need to be able to predict the active stimulation, not the sham, okay? It's clear this? Okay. And we found this. We found that it was able to predict the performance only in the real TDCS group, in the active TDCS group, but not in the sham. And also here we can conclude that cognitive reserve measured with a life experience questionnaire. So that take into account not only education, but also what training activities you have done, what work you have done, what leisure activity you are involved, you have done, and so on. Predict the effect of TDCS, in particular memory enhancement. So accounting for individual differences in cognitive reserve at baseline, because it was collected before doing TDCS, okay? Help to explain the responsiveness of TDCS. Obviously, this explain only a percentage of variance. We know for multiple regression, you know how much variance is explained in the dependent variable. Probably we need to include other factors like potentially maybe biomarker, fluorescent state or structural MRI and so on, to be able to predict more of the response. But this knowledge may contribute to optimize the use of TCS in older adults, okay? So what we have seen that the dorsolateral play a causal role in strengthening verbal episodic memory through reconsolidation. TDCS apply over prefrontal cortex enhanced delay memory recall in older subjects. TDCS through reconsolidation seems to be induced long-lasting effect than TDCS during encoding. TDCS through reconsolidation enhanced delay memory recognition in subjective memory impairment and MCI. Cognitive research predict TDCS-induced episodic memory enhancement. And we found no effect of TDCS over posterior parietal cortex through reconsolidation, okay? If you want to read more to have a better view, I wrote this review a couple of years ago, but there were all the TCS study, the transcranial electrical study on episodic memory, physiological and pathological aging. And finally, but not least, I would like to thank you, Leonardo Cohen and Maria Cotelli and Rosa Manenti for the help in testing older adults and patients in Italy, and you for your time and consideration. Yeah.
Well, thank you very much. Thank Marco for your very nice talk. I think very clear in many senses. Creo que es el momento de aprovechar la presencia de Marco y que podáis preguntar lo que queráis o que podamos incluso iniciar un pequeño debate. Eso estaría muy bien. Yo creo que lo que ha presentado Marco, algunas de las cosas que hemos visto esta mañana permiten pues especular un poco sobre el futuro de la técnica de neuromodulación, sobre sus cuestiones éticas, que también las hay, no las hemos tocado aquí, pero se podría hablar largo y tendido también sobre aspectos éticos y es vuestro turno en realidad. No sé si queréis preguntarle algo primero a Marco antes de poder iniciar algún turno de debate, como queráis.
Preguntas pueden ser en español y las traducimos bien.
So thank you very much for your presentation. It was very clear, very nice. I wanted to ask if we have patients with PTSD, with post-traumatic stress disorder, and there is a psychotherapy in English, eye movement desensitization and reprocessing. So do you know about maybe combining TDCS with this kind of psychotherapy? Does it make sense to?
Yeah, potentially yes. Yeah, potentially also you can apply with CBT also. But this technique seems to work quite well based on what I heard from psychotherapy. But for implication for PTSD, I'm doing something different. I'm looking mainly more at intrusive memory of trauma. That is a core feature of PTSD. And so I'm using the same reconsolidation idea. So we show a traumatic field paradigm on day one. So where they saw some scenes about accident, people cutting their head, cutting a hand, and so on. So that evokes traumatic memories for more or less 1 week. This is a famous paradigm. Then we bring back 24 hours later. We show some neutral cues about the field, and then we apply TMS, inhibitory TMS, try to reduce the, and people in the meantime collect on the diary on the phone. When they have intrusive memory, they have to record. I have a visual intrusive memory. The intensity was quite medium, high, and so on. I have a thought about intrusive memory, verbal intrusive memory. And so basically with stimulation of some visual cortex, also Broca's area, we are trying to reduce the frequency of this intrusive memory, or the intensity at least. This is a project that I'm doing with a PhD of mine, yeah, but probably the application with other techniques to use for PTSD, I think is more the future. Try to combine more intervention together. Like you apply in cognition, like using cognitive training, maybe, okay? Yeah.
Preguntas, insistimos en la posibilidad que preguntéis en castellano y la traducimos. No quedéis con, no vayáis a dormir mal esta noche porque tengáis preguntas sin responder. Luego puede pasar.
Marco, I have a question, just one question. It's a pity that you found the effects with cognitive reserve, because what happened with patients without cognitive reserve? TDCS is not useful?
No, what I found, yeah. I found higher cognitive reserve, yeah, better recall.
There's a predictive.
So I have to speculate a little bit based on what Stern said. But at the beginning, cognitive reserve, higher cognitive reserve seemed to be a protective factor. It's also there is some brain changes, you perform better. But based on Stern is when the pathology reach a level, people with higher cognitive reserve, they decline faster. Yeah. And so my speculation was that probably when the pathology reaches a certain level, this will be an intervention to do for these people.
Mm-hmm.
Yeah, because I had a little bit of a hard time to try to explain the data, because what does it mean? High cognitive reserve, better recall, so what? I can apply TCS only in people that are great, that are better than other people.
Exactly.
So, but anyway, it's only a percentage of explanation, because we did the same studies. We reanalyzed the data also with subjective memory campaign and MCI. We put together, but cognitive reserve is a good predictor, but both groups. So predict the performance in both groups, sham and real, so it's not able to really predict the memory enhancement. Yeah, but also encoding predict, but then predict for both groups is not so sensitive to TCS, but we need to investigate more this potential inter-individual factor or potential biomarker. In particular, biomarker, I think, is quite important.
It could also be that a different TCS protocol could be more effective for these people.
Yeah, absolutely.
So we are not just saying that the same protocol is effective for everyone.
Yeah.
So you can just change parameters in terms of, or even the network evolved could be different in terms of or the vulnerability to how prone they are to be benefiting from these effects. Could be.
Yeah.
This is something to be investigated, actually.
Yes, this is a thank you for your presentation. This is a question for all of you, because I'm very worried about the long side effects. Even the water, you know, if you drink a lot of water, there are problems in your electrolytes, no? Even. So these experiments are double-blind experiments, and any double-blind experiment is prepared to analyze some results. So, but it cannot show the long side effects in another aspects. Maybe morality, maybe my moral action, my moral point of view, maybe I can enhance my memory, but I can have problems in the long side effect, 1 year, 2 years, in my speak, my audition, my any point of view. So what are the experiments that are analyzing the long side effects of these techniques? Bueno, se lo digo al resto, me preocupan mucho los efectos a largo plazo, entonces aunque se hagan experimentos de doble ciego, los experimentos de doble ciego analizan lo que analizan. O sea, yo quiero analizar un nivel de sodio en sangre y es lo único que voy a analizar, aunque salga otros resultados no están cubiertos por el doble ciego. Entonces, ¿qué efectos a largo plazo se pueden producir? Porque bueno, todos conocemos efectos a largo plazo de medicamentos, de fármacos y por supuesto soy un fervoroso del avance científico, pero creo que esto es un tema que hay que considerar. Muchas gracias.
Marco. No, he won't. No.
If there is anything, if there is any action about this problem.
No, not to my knowledge. I mean, first of all, because I'm talking in English, just translate it before, after this. No, and I think the same problem can be applied to any other intervention, any other, attempt to modify behavior, actually. In principle, there are not many dangerous long side effects to be expected, but yes, you are right. We don't know. And actually, participants go through the lab, or the clinical, and they move, they go, they leave, and we don't know more about her or their changes in behavior or neural activity. We don't know because they are not going through the lab again just to check for this. There could be changes at this level. They could be. They are not expected, at least in terms of huge changes, because I mentioned before, many people think that the effect of neuromodulation is not real at all. So this is hard to combine. So there are not effects, but it could be long side effects. Well, for now, we know things like this. We're showing any other things are also being investigated right now. But the long side effects are to be explored more, probably more in terms of in clinical settings, but also in just one session in the lab where cognitive neuroscience is a very interesting thing to be addressed anyway. So you're right. I don't know if you, Marco, want to say something.
Yeah, you raise a very good point. Some studies, they have also long-lasting assessment, maybe after 6 months, 1 year, so you can have a better idea if there is some concern or some complaint. Some not, I don't know. If people don't show up and say, I had these issues, we don't really know. Because if you don't monitor the person or involved in the trial for a long time, then you need to hope that the person is going to show up and say, oh, I had this issue, maybe it's related. Or it's quite difficult, yeah, but it's a good point, yeah.
Regarding TMS, for example, it has been used for the last 15 years, more or less, 15, 20 years. And side effects, if you don't have a study that analyzes these side effects, it's very difficult to identify. But usually you expect that patients, if they have side effects, they report side effects of the technique or the treatment. After a treatment, a pharmacological treatment is approved, some side effects are being not notified. And regarding TMS, for the last 15, 20 years, there have not been reported side effects or long-term side effects. It has happened with other techniques,
for example, ECT, the electroconvulsive therapy, there are patients that do say, okay, maybe I am a small percentage of people that have a cognitive side effect long-term, but in TMS, for example, I haven't heard about long-term side effects.
Yeah.
Question over there?
It's related to this question. If you could design an experiment to study these long side effects, what would you be most worried about? What would you think would be a good thing to look at? What sort of things might actually be affected? You guys know a lot more about this than the rest. Is there anything you're more afraid of touching?
Maybe it could depend on the technique you're using. It's not the same thing TMS, but TCS, for example, because the energy you're applying is not the same. The consequences of this at the neural level is not the same. Maybe because we are just looking at these kind of parameters like functional connectivity, brain oscillations, performance in basic neuropsychological tests could be just one first step to take. But I don't know, I should have to rethink about this because I really don't know. But probably the same parameters we are just trying to modify could be the relevant ones to look at. It's my insight right now.
No, it's okay.
So in many of the studies you both have talked about, even Alejandro as well, there was a lot of variability of the effects. So some patients it works, some patients not, and some subject it works. And so how can we do a personalized stimulation? Can we do that? Is it because you are typically having groups of patients, okay, all MCI patients will receive TDCS in the left prefrontal cortex or depression patients, all the same. But can we personalize that? Base it on, I don't know, biomarkers like functional connectivity or any other? I mean, I don't know. I mean, I don't want to bias your answer, but...
Yeah, absolutely. I think the biomarker probably they're gonna explain more, but not only biomarker, also some maybe cognitive tests or cognitive function, or some questionnaire collected the baseline can help to explain the variability we need to address if you want to go in the direction of a precision medicine. This is quite important. The future is to go for some precision medicine. I don't want to say that ECS works for everybody. It can work for you, but not for you. What is the difference? Maybe some difference in the connectivity, some difference, I don't know, maybe in cognitive reserve that can explain, but it's not that what I show is a huge explanation of the variance. No? You know, for multiple regression, you need to explain much variance. If you try to explain at least 40–50% is already a lot in a multiple regression model. You know, you don't explain 100%. But if you want to go probably in the precision medicine, we need to more the biomarker. Why now there is a lot of emphasis? We don't want to see more study that enhance memory for 1 week or for a month. Now we know that it's possible, but how we can optimize? How we can optimize that works for more people? I don't know. In terms of cognitive function, is a different world. It's quite more very, very difficult. Why there is nothing approved? It's all experimental. There is no treatment for memory, no treatment for language, no treatment for attention. But seems to work better is more in depression, more some psychiatric component, but also now I have also a lot of requests for psychiatry try to want to improve episodic memory, schizophrenia. Schizophrenia is a huge problem in episodic memory. A huge problem, not only working memory. Episodic memory is a big problem for schizophrenia. It's recognized by a study by Ragland and Carter many years ago with fMRI. And so people want to know But I say, you can try something, but I don't know what you say.
Yeah, I agree. So I just could say that maybe a first step could be just identifying factors that could be predict more or less activity in terms of each of every technique. I have been talking about EEG in resting state. We have been talking about scores in the mental when we're talking about dementia patients. So there are some factors that could be predict more or less effective neuromodulation benefit or not. And if we identify them, we can just consider them better. And also maybe adding more measures when we are conducting experiments, adding variables like cognitive research, even in younger participants or not so old participants. And any other variable could be predictive of benefit. If we add this type of information in 10 years, we could be just get a database that could be very informative about how to modulate depending on which features participants have.
And also, sometimes there is the idea in cognitive science that we need to show first in healthy young participants, then to move to some population. No, we don't need. In animal studies, they do preclinical and then they move to patients. So sometimes we don't need to show an effect in young adults and move to patients. Because in my data, I found many positive data with older adults. I published recent 2 studies with young adults, didn't get any effect. With prefrontal cortex, ECS, same montage during encoding. So it depends what question you really have. Sometimes you can have questions that are more in understanding the mechanism to develop something that maybe can be used to enhance or to improve.
Yeah.
But not have the idea that I have to show that enhance memory in young adults first, and then I can move to MCI. Because you can test memory that is already, some participants already a ceiling effect, and you can have a lot of issues. So think more in terms of a research question, what you really want to address. And don't think only that it's easy to enhance something. Start to think also more in the mechanism that could lead these techniques to enhance. Okay? Nowadays, to show that ECS enhance attention memory, you don't publish in stupid journal, really? People say, oh, really? Are still people doing a study to show that you enhance memory? No, they want to know more in terms of the mechanism also. Yeah.
Also, when looking for biomarkers or anything that can predict a response or a remission in a patient, for example, with depression or with any other pathology, there is a very challenging thing that is not only identifying this kind of biomarkers, but from a clinical point of view, it has to be something that patients can access to those kind of I don't know, fMRI, for example, or EEG, or whatever is the biomarker. So there is also another challenging part that is identifying these biomarkers or these kind of predictors of response, but they have to be something that people can access. If it's a very expensive thing, absolutely, it's not going to be worthy trying. Maybe it's better to just start the treatment. If it goes well, okay, and if it doesn't, I mean, if there is no response, just stop. Because
and also the future is going to show that the combination of different techniques
absolutely
is going to address more questions. Combination, for instance, non-invasive brain stimulation with neuroimaging, EEG, resting state, fMRI, or spectroscopy to understand more the mechanism. Because we can think we know the mechanism. No, we don't know really the mechanism, how it's going to act on the brain. Some studies, there are less studies in animals also. that can help to understand more. There are less study in animals. And this is a problem for humans. If we look at the Science Nature paper, 95% are studies in animals to study the mechanism. In humans, we are limited on what we can do. So why the integration of techniques can address some important questions, I think.
And theory-guided investigation as well helps.
Yeah, the theory is good.
That was exactly the direction of my question. Is for example, why not we use more network theory to predict what are the targets to use for stimulation? Because it looks like we are many studies they are stimulating Rodriguez. I mean this left prefrontal cortex, and because it is a good target, or based on the specialization of brain regions, is a region involving many cognitive functions. But this is just based on theory, based on statistics. But the statistics
based on the lack of controls.
Exactly. So why not we use personalized networks to try to target specifically in each subject? So there is a very nice paper by Pasquale Leone about this exactly. He was saying, okay, we have to find the hubs, exactly the hubs of particular persons in particular pathologies to stimulate, and then it will work. Otherwise, we will be stimulating in statistical regions, but not in personalized regions.
Yeah, one of the biggest things about this paper, that is the Stanford Accelerated Neuromodulation Therapy, the one that is so effective with 10 sessions per day for 5 days, is that they do use they don't stimulate F3 or dorsolateral prefrontal cortex. Yeah. They look for the most anticorrelated point of the DLPFC with the cingulate cortex, and they stimulate with neuronavigation exactly that point for 5 days. So they are, I think they are the first group to prove that you can stimulate based on connectivity or on functional neuroimaging and be effective, or very effective, because it's the most effective protocol for the moment with
But also I think the closed loop stimulation is very promising. So you monitor some activity, and then based on some signal you deliver the simulation.
That is really good, yes.
Yeah, this is very good, but always. These require also collaboration with, also if you are psychology, maybe with people that has more expertise. Because sometimes you cannot do all by yourself, you have all the expertise to do something. But yeah, collaboration I think is the best way to have some question and to ask this question with people with more expertise that you can maybe try to test. But as Carlos said, or Fernando said, the theory behind is very important for each study. Also, if you do just behavioral studies, it's important. Not only. Why I think is one of the limitations of the neuroimaging. Neuroimaging was great, but when you want to try to address in one single study a lot of questions, it's something that people in experimental psychology were doing maybe 10 experiments to try to address a point. Yeah. So this is, you know, it's expensive, but yeah, but we pay a price in the other things. And now the problem is going to be in resting state. We think the resting state without applying any more theory is going to resolve all the problem. We are not investigating more any task-related activities. So there is always a balance. But this continuous science is taking a lot of trends. Now there is a lot of resting state interest. Now a lot of biomarker. But at some point, we pay a price. I think. And when we need to come back,
Yeah, but
yeah, we
the
not
nuclear
always
operation-
follow that some topic. Also, response inhibition was our topic 5 years ago.
yeah.
GACS seems to be alternative current stimulation. Yeah,
To fix everything.
okay, but we don't need to do because it's trendy. We need to do what we like, what question we have, and try to address this question. Okay? This is quite important, I think.
Regarding to something that was mentioned before, what about using these neuromodulation techniques with kids, like for example with Down syndrome or other diseases like hyperactivity or something like that?
Kids, what do you mean? What age?
Children, ADHD, autism, Down syndrome.
There are some studies already done. Yeah, maybe less with TMS, but also with TMS there are some studies. Yeah, but you know something more?
I mean, I know that there is not enough evidence to start applying clinically these kind of treatments.
Yeah,
in kids.
but there are some studies.
Yeah, there are some studies with TMS, with TDCS2, with other neuromodulation techniques that they are very interesting and they have many positive results. So.
One another things that we discussed also with Fernando and Carlos, don't use TCS for recreational use, okay? Don't try to put some electrodes on the head because you can buy some product, you can build also TCS and try to improve your language. Don't do it, please, because there is a lot of study behind about the parameters.
Yeah,
But
yeah.
a lot of people are doing this.
There is just one, because we are touching an ethical question, and that was part of the debate for today, to touch this type of questions. And of course, doing neuromodulation in kids, Carlos said this morning, I mean, it's going to be difficult because you change the neurodevelopment, the normal the neurodevelopment, but sometimes we wanted to do it because the kid have ADHD, autism, or whatever other disorder. So we need to do it. So at what extent this is, or I mean, what is the limitation for in children for the use of the neurostimulation? Can we do it in learning disorders? Not in clear pathological conditions, in things that are more in the limit of being pathological or normal, like, I mean, learning disability, or, I mean, someone who doesn't get very high scores, let's say that way.
I mean, children are being treated pharmacologically. They have been treated for the last, I don't know, 30, 40 years.
That's interesting.
With methylphenidate, lisdexamfetamine, antipsychotics, benzodiazepines, antidepressant drugs. And these pharmacological treatments have an effect on their neurodevelopment. They may have side effects, they may have positive effects, and they are already being treated for ADHD. They are already being treated in autism when they have some, like a lot of impulsivity or other kind of alteraciones conductuales. So, I mean, it's something that I think we also have to compare the benefit of what we already have, of traditional treatments or pharmacological treatments, and compare them with non-invasive brain stimulation techniques, and check if these kind of techniques have a benefit over a pharmacological treatment regarding side effects, for example, or effectivity. So, I mean, it's something that I don't think there is enough evidence, but I think it's a very wide research topic that should be promoted and to try and develop alternatives to what we have right now.
Yeah, and I just mentioned this morning, I know people just using TCS, which is quite safe, dealing with dyslexia in children. It's probably is not a problem in terms of the consequences for neurodevelopment of these children, but maybe the benefits could be better, because We don't know, actually, so it's hard to say. But there's no real protocol to define how to proceed with them. We don't know. It's just a question of the society which is promoting this, or the contrast with the neuropharmacology, or something. This type of criteria could be just being used to make decisions about this. This is my view, at least.
Sí, bueno, yo la iba a hacer en español, que estoy más cómoda.
Haces bien.
Luego se traduce. Bueno, quizás es una pregunta muy básica, pero se me ha quedado ahí un poco la duda, porque hemos estado hablando sobre las diferentes patologías y sobre cómo ellas muestran patologías y características a nivel morfológico y fisiológico, pero me ha quedado la duda sobre si existen cuadros clínicos en los que presentan una fuerte sintomatología, pero cuando se realizan estudios en imagen o con las técnicas que haya que desconozco sobre el funcionamiento de su cerebro, presentan un funcionamiento normal. Es decir, si hay pacientes que no se entiende bien el por qué presentan una cierta sintomatología. Y luego, relacionado con ello, tengo una pregunta ética, pero no me ha quedado claro si estamos en la parte ética ya. Sí. Mi segunda pregunta era: ¿hasta qué punto en el ámbito científico actualmente se especula sobre la aplicación de este tipo de técnicas en pacientes sanos? Un poco relacionado con el título del curso de ¿se puede mejorar la actividad cerebral? Bueno, pues ¿hasta qué punto existe un interés en ciertos ámbitos científicos de ver los efectos de esta estimulación en pacientes sanos simplemente por la mera curiosidad humana? Gracias.
I could try to answer the second, but not the first one. Fernando or Alejandro, maybe.
No. I understood what I know.
Bueno, me puedes responder en inglés, pero...
There are many mental disorders, for example, and some of them they are better understood under functional connectivity and how the brain works, or neurocircuitry, and of course there are other disorders where we haven't identified yet this abnormal brain functioning. We also have, for example, personality disorders. In personality disorders, they are not considered like a schizophrenia or a bipolar disorder or a depression. It's just that people have personality traits that are, compared to their cultural surrounding, maybe higher or lower than expected. No? For example, impulsivity. Maybe depending on which country you live in, people are more impulsive or less impulsive. And if you are living maybe here in Spain, you may have social problems, family problems, or laboral problems because you are more impulsive than what you are expected to be. Maybe this kind of personality traits, maybe they don't have, or we haven't identified yet for some of them, abnormal brain functioning. Also, we need to recheck if we are using the proper approach, because, for example, in this closed loop neuromodulation paper, they were talking about dynamic processes where people may have or may not have this kind of abnormal brain functioning, depending on the moment when you are evaluating the patient. I mean, there are patients that they may be diagnosed of a disorder, and maybe you do an EEG, it's going to be perfectly fine. You do an fMRI, it's going to be perfectly fine. So I don't know if that means that there is no abnormal brain functioning, or that means that we are not detecting this kind of alterations. La segunda pregunta.
Regarding the second question,
The second question is about the scientific interest in terms of improving cognition in healthy people. Well, actually, the main group to test hypothesis of this is healthy people, so they psychology students, basically. So the idea is not to get them to go better or to be super intelligent people. It's not the idea. The idea is just, can we get better performance in them? That's it. Okay. In some cases, some people try to extend this idea, maybe just try to stimulate different hubs in order to get better memory, better attention, but usually this doesn't work. Okay, but actually the main group or the main type of experimental group to test the basic ideas on this are healthy people. If not, the aim is not to make them better. Instead, the idea is just to know the relationship between how you're stimulating such or this network. You are changing your behavior. Sometimes you get better performance, but sometimes you get a worse performance. So you can reverse the question. Can we make people less intelligent or forget more? Yes, I can. But it's just temporary, in very controlled conditions, by using very specific tasks. You know, it's not. This is the scientific context. It's not that. I don't know if I answer your question. Okay.
Also, in particular regarding TMS can be applied online or offline. What I mean, online can be applied during the task, for instance, during the encoding or memory task, during the retrieval, or can be applied offline. For instance, you apply for few seconds, like for theta bars, or maybe 50 minutes at 1 Hz, and then you have after effects. So you do stimulation, then you do the task, and you see the effect. Okay, but I did the online TMS for years. I always found interference. So the performance was decreasing in people. Yeah, but you were showing the contributor on some area. But it's important knowledge, but you need to acquire also based on fMRI. Studies show the involvement of frontal area, parietal cortex, that can be correlational driven because fMRI is based on correlation. And we know from the first year that correlation doesn't imply causation. And with TMS, we were addressing the contribution of this area. So we were zapping one area and see if the performance changed. And this was important in terms of knowledge. Then, based on some using TCS or some specific parameter of TMS, we can try to enhance. But this can have far-reaching clinical implication, I have to say. So it's also important to understand more the mechanism. Also
So, bueno, una cosa que para mí es muy clara y creo que es una... I will then say in English. Una cosa que para mí es muy clara y que creo que debe ser una buena conclusión del curso es que la neuroestimulación no es algo fácil. No es una cosa tan sencilla como pongo 2 electrodos y estimulo. Y esto es lo que la tendencia, y lo quiero traer al debate para vosotros, la tendencia que se está haciendo. Es decir, bueno, como es algo que está funcionando en la ciencia, lo voy a llevar inmediatamente al mundo clínico sin ningún filtro. Es decir, voy a aplicar lo que he leído en un paper y ya está. Y voy a decir que yo lo hago en mi sitio o lo hago donde sea. Y esto puede ser peligroso. No sé qué opináis, si os parece que esto... I'm talking about to translate the scientific knowledge to the clinical scenario directly without any filter and using it like without no tomorrow.
Muy rápido en castellano porque me tengo que ir. Eso es uno de los principales problemas con los que nos hemos encontrado en psiquiatría, por ejemplo, y es que tú pides un presupuesto, viene una empresa, te deja un aparato de estimulación magnética transcraneal, te dice aprieta este botón, este otro, ponlo aquí, esto es para depresión, esto es para el TOC, se van y a partir de ahí tú ya te apañas, ¿no? Entonces, la facilidad que hay para adquirir un aparato de estimulación magnética transcranial es llamar por teléfono y que te lo traigan, y con la TDCS pasa igual. Los venden en Amazon, hay tutoriales en YouTube para hacerte tu propio aparato de TDCS, y también te venden los aparatos fácilmente, ¿no? Sin ningún tipo de formación, no está regulado. Entonces, esa es una de las cosas por las que es muy importante este tipo de cursos, o cursos en los que se hable un poco de la parte teórica, de cómo aplicarlo de una forma segura y de no venderle a un paciente, a todo aquel que entre por la puerta, tengo estimulación, esto es para ti, tengo TDCS, esto es para ti, y encontrar si hace falta, en qué momento, y siempre valorando la relación coste-beneficio del tratamiento para los pacientes, ¿no? Si no, los pacientes, si no va a ser perjudicial para los pacientes, va a ser pan para hoy, desde un punto de vista económico para la gente que lo aplique, y hambre para mañana, porque se van a desvirtuar estas técnicas en cuestión de pocos años. Entonces, bueno, esa es mi principal reflexión, es que cualquiera que se quiera dedicar a esto, que reciba una formación, que se preocupe de aplicarla de forma ética y correctamente, o en función de la evidencia que haya, y desde luego trabajar desde el principio con indicaciones aprobadas, por lo menos por parte de la FDA y por parte de la CE, como es la depresión o el TOC, y luego ya veremos si en algún momento se puede aplicar fuera de ficha técnica, pero si no, pues con mucha prudencia y mucho cuidado, por eso mismo, ¿no? Por no perjudicar a los pacientes y ir siempre en su beneficio, a nivel, desde luego, coste-beneficio con todas las herramientas que hay. Me disculpáis, pero yo me tengo que ir ya corriendo. Muchísimas gracias a ti.
Más. Vamos, yo me gustaría que continuáramos con algunas otras cuestiones, pero seguro había una cuestión de la audiencia. Sí, mejor de la audiencia.
Gracias. Carlos ha dicho una palabra clave: comportamiento. Yo creo que la mitad de vosotros, si no todos vosotros, habréis leído el libro de Yuval Noah Harari, Homo Deus, en el que describe un experimento de TMS con una periodista, y el perdía el miedo. De hecho, un experimento, una aplicación de TMS, y perdía el miedo. De hecho, era un experimento, bueno, perdía el miedo ante una prueba de disparar una serie de blancos. 27 blancos, acertaban todos. Es un autor tan fuera de duda como Yuval Noah Harari. Me gustaría saber si conocéis algún otro ejemplo más de modificaciones de comportamiento posibles en algún paper que se haya publicado. O, ya os digo, en este caso específico era TMS, creo recordarlo con exactitud. No sé si en otra técnica.
Voy a contestar en castellano para hacerlo más rápido. Mira, sé que intentos ha habido muchos, creo que quieres decir comportamientos más, se refiere a cuestiones más de mayor impacto, como puede ser juicio moral, ese tipo de cosas. Te voy a poner un ejemplo que claramente demuestra lo difícil, como decía Fernando, que es en realidad obtener efectos claros en TDCS o en TMS o en TACS. Hay bastantes intentos de ver si se puede hacer que la gente mienta más o mienta menos, la investigación sobre mentiras, por ejemplo, utilizando TDCS. Bueno, también utilizan otro tipo de procedimientos, y es tremendamente difícil. O sea, no, incluso tocando hubs, I'm talking about line and TDCS or TMS on the networks involved in telelines. Y prácticamente no hay ninguno que consiga, estimulando hubs que sabemos que son fundamentales, porque aparecen en EEG, en fMRI, como elementos fundamentales a la hora de poder mentir o retener una mentira y decir verdad y ahora miento y ahora no. Cuando estimulas no cambian los patrones. Y eso ha habido mucha gente interesada en eso por cuestiones legales, por cuestiones de testigos oculares, por muchas cosas. Y no se consigue prácticamente nada. Y te lo digo yo, que colaboré con una gente que son expertos en mentiras. Hicimos un experimento muy bien pensado, y como otros muchos, era muy difícil obtener cambios en ese nivel. O sea, que una cosa es poder conseguir beneficios en una tarea de memoria episódica o de vigilancia, ahora y tal vez mañana o tal vez dentro de 30 días, y otra cosa es que entres al laboratorio siendo de una personalidad y salgas siendo de otra. Eso yo no me lo creo. Eso sí que, bueno, no es que no me lo crea, es decir, que soy muy escéptico. Me gustaría ver ese resultado que has comentado, que lo conozco, replicado. Para empezar, igual que quiero ver replicado algunas cosas que me creo rápidamente, te digo...
Duraba una hora, 90 minutos,
sí,
como habéis comentado.
Eso es. Es verdad que eventualmente tú puedes encontrar efectos de este tipo que son muy llamativos, Pero, por ejemplo, hay mucha literatura en el ámbito más de la psicología social, de gente que ha ido tratando de conseguir efectos sobre moralidad, sobre lo de mentir, sobre aspectos emocionales, y algunos tienen efectos pero son muy moderados y, por supuesto, con una única sesión no duraderos para nada. Pero el mejor caso, creo yo, es el tema de mentir o de decir la verdad, ¿no? Haciendo y con eso que aparentemente conocemos relativamente bien cuál es el funcionamiento a nivel cerebral y de algunos procesos, pues no se consigue manipular para nada. O sea que es posible, pero yo creo que conviene no ser tampoco... Mira, con la estimulación en general sucede como con muchas otras cosas, ¿no? De repente hay gente que es como muy pesimista y son críticos, pues ya te digo, como para decir que la corriente eléctrica no puede atravesar el cráneo. Todavía hay gente que lo piensa, y hay gente que se piensa que con la TDCS o con la TMS puedes cambiar el mundo. Y hombre, una cosa es lo que estamos hablando aquí, de tratar de dilucidar qué mecanismos pueden ser modulados, de qué forma, que no es fácil, sobre todo en pacientes que son que pueden ser más receptivos a ese tipo de... La cosa es que podamos buscar eso, y creo que hay muchas razones para buscarlas, y otras, como hacen algunos gente de negocio, vendiendo aparatos de TDCS para fortalecer tus músculos y que corran más rápido. Pues eso, yo creo que eso no está dentro del ámbito de la ciencia, eso está dentro del ámbito del negocio, fundamentalmente. Te pongo este ejemplo, que no en otros, pero en esto tiene más que ver con hacer negocio que con la ciencia. Y eso se aplica a muchas cosas, y también a la psicología y a la neurociencia, lamentablemente. Y es verdad que algunos científicos, también tengo que decir que creo que se prestan a eso. La mayoría no, pero algunos, pues supongo que money is relevant.
¿Más cuestiones? ¿Tiene alguna otra pregunta? ¿Alguien tiene más preguntas? ¿Nadie tiene así algo que quiera preguntar? Javier.
Marco, I hope I understood properly, because otherwise my question has no. I've been a little bit concerned, a way of speaking, the relationship between the traits. You say that the individual trait has a relationship like family, work, and leisure has a relationship with the results.
To predict, yeah.
Do you find these traits are for you like stressants of how they work in the...
Yeah, for now we just started to explore a little bit this cognitive reserve. So this education, working activity education, we don't know if other personality traits, stress level can predict. Some people found also some cognitive function of the baseline, some capacity of the baseline to do this task can be used to predict. I don't know, I really don't know, because this is quite interesting, but it's playing not too much variance. So there are a lot of factors contributing to the model to explain the TCS responsiveness or TMS. Why we need to understand more. This is very important also to optimize its use, to go in the future over precision medicine. So maybe you, based on your characteristics, you need more pharmacological treatment, not TCM or TMS. So because why some people respond more, some people less?
Yeah,
when you have only asking questions, not super difficult, learn a list of 20 words. And very cool. It's not that they have to solve a complex mathematical problem that some people can do. Some people know. We should all be able to remember some words. And also why some people can be used. We know that some people have different strategies, some people are better in doing something and not. But this should be able to predict both response groups for all. And this is fine. For this encoding performance, predict both groups, okay? predict sham and predict also real active. But why something predict only the effect of TMS? What is going on in our brain? And it's so complicated sometimes. And we need to figure out more understanding also based on theory, like he said. We can use some prediction, but also prediction based on some theory. Also, we can use resting state, we can collect data, but we should have also an idea of what to use of the resting state. But yeah, but in say, and for instance, the issue of memory that I'm realizing now that I'm doing this new study about intrusive memory of trauma, we got a lot of grief from the ethical committee because they said, what happens if you do an intervention, you try to disrupt memory? We are trying to disrupt mainly the emotional intensity of the memory, or try to reduce the frequency of this intrusive memory. But what happens if you disrupt the memory? It's not legal to disrupt the memory of a person. This can have a lot of legal implications. So we had to introduce a test of recognition memory of the trauma field paradigm. We are going to assess pre and post TMS, the trauma field paradigm. So we should be able to reduce the frequency or the intensity of the memory, but not the content. The content should be intact. Otherwise, we are creating some ethical problem.
Yeah.
Yeah. So. Yeah.
Yes.
Okay, I think I understand. Let me ask you.
What is your concern?
No, my concern. The way you make these treats of the individual, the way you put it in the experiment. How do you experiment? How do you get data from there and use in the experiment? I don't know if
So, we collected data already acquired in previous experiment.
Yeah. On this.
So all the participants, when they came to the experiment, they completed a neuropsychological evaluation. So they did all the tests about memory, language. They completed some questions about anxiety, depression, and one was this cognitive self question. You complete this, and this was some information collected at baseline before doing the TCS. And so then we put together all the data collected when TCS was applied at different time during encoding or reconsolidation. Try to detect some inter-individual factor that can be used to predict, and why we found that cognitive reserve. Yeah, but as I said to Fernando, predict for healthy adults seem to predict the same paradigm, but in subjective memory impairment or MCI is not so sensitive. Yeah. So I don't know why. It's able to predict both groups, but it's not so specific for what we call TDCS-induced memory enhancement. And also why people that has better cognitive reserve has better memory. We know this, but why should we be able to predict only these people? Because it's a positive correlation. It's not that we are able to predict the performance of people with less cognitive reserve.
But there is a very nice message behind that, which is you should be very healthy. You should do cognitive training. You should do physical exercise. You should
these are some
even if you are not elder. You have to do it right now in order to have a good network.
Yeah,
and
this I
to be
think is the
prepared.
main message in general. You don't need to open some point to use GMS or TCS. Maybe IFE life can delay a little bit. Maybe you can get anyway. Also, if you have high coin reserve, at some point you are better, okay? You compensate better. But as the model said, when the pathology reach some level, you have a much faster decline. So, and why I'm in the paper I say probably for these people when at some point the level is rich enough, a TCS intervention is good for these people, but is able to predict is not that is something that people found generally. Some people found, some people not. Depend also how many patients you have, what paradigm, I don't know.
But in this type of context, the comparison between different techniques could be very interesting because TDCS could be not good enough, but TACS could be good because the problems are originated by a different pattern of neural activity. That's the point. But we need further investigation in order to get better comparisons and better ideas about how to gain understanding of the effects, etc., etc. Yeah, that's the point.
Okay, no?
Also, we need more replication in this field.
Yeah.
There is a big crisis now, first in psychology, second in cognitive neuroscience or neuroscience. We have problem to replicate the basic findings because people want to reach always something novel. This is the goal. You want to replicate, it's not interesting. Where are you going to publish? It's true. Where are you going to publish? Now it's much easier to publish negative results compared to many years ago. Many years ago was almost impossible to publish negative results. Now, thanks more to more open access journals, there are more interest in knowing what's going on because also negative findings can be informative.
Absolutely.
If you have done something, you didn't get any result, I'm going to try to avoid to use the same parameters.
Yeah.
So it's informative, but you don't go in big journal for negative findings. And now there is more pressure. Society putting more pressure, getting good paper, getting grant. So it's tough, it's tough. There is more expectation. But we are going to pay some consequences because some data are not reliable there. Maybe also some big paper because they're not being replicated. And a lot of people may be working on something, but maybe it's not true. I spend a lot of effort, try to work on some theory or some idea, but maybe it's going to be not confirmed. Yeah.
Pues venga, hacemos la última pregunta. Con esto terminaremos. ¿Hay alguien más que tenga una curiosidad o tal?
Well, some comments ago, you say that, for example, in your experiments, the neurosimulation worked for MCA patients or in very early stages, but when you try to replicate in young adults, healthy young adults, they didn't show any result. What we can say about that, that maybe in some points there are no effects of the stimulation, maybe because of the stability of the networks, or there are some conditions where we can work on that, or on the other hand, maybe we can find, for example, we speak here about the problems of applying neurostimulation during the childhood or adolescence, but maybe those are even time windows where we can apply this neurostimulation to obtain some effects more than in young adults that we saw that, and in other papers I saw that it's very difficult to modify this activity.
Yeah. Yeah, it's a good point. It's a good point, absolutely. And so what I could not able to replicate was some effect on encoding in both regarding recognition or recall. With a PhD student, I used the same parameter of my study because his PhD was based on my study on the encoding published in 2016, and he tried to replicate, but I don't know. I don't know also if I'm gonna able to replicate the data with the encoding or the other or NCI, to be honest. But why I was very proud to see that David Butterfras replicated some of my data using the same paradigm, because it's not reproduced the same or as the same finding. It was replicating the experiment. But I don't know, we need to understand more maybe on the system level what's going on in terms of network or interaction. Yeah.
Mm-hmm.
I don't know what you want to add something?
Not really for this question. It was mainly for you.
Carlos?
An answer to the question? Well, it's hard to say because in some experiments you get some effects in younger people that you don't in older people. At times it's the reverse pattern, which means that we are dealing with different brains, different states, but also different methodologies, different size of electrodes, size of different intensities, a lot of elements that could be just making a difference. And this is why I just ended my talk talking about the relevance of, the importance of replication, as Marcus said, replication, better methodological qualities, and we need that. We need that. And so remember that the neuromodulation investigation is in its early years, and we need to make progress at different levels, not only just showing that we can improve memory, also just showing that we can replicate effects, we can make very different things, and that's the point, and probably this is why we are here today.
Mainly.
And also, you need to know, to understand that when you test young adults, mainly you test students. Mainly you test students in psychology. They are well trained to do experiment. If you test normal people, maybe they will say, why, it's so boring, that's why I have to do experiment. Sometimes you introduce more variability also. So we are selecting some specific participants. We are not applying so ecological validity to extend to the entire population. We can generalize to the entire population, something maybe, but something not, I think. Yeah, but this is what we can do.
Okay. Bueno, pues I'm going to close the session. Bueno, muchísimas gracias a todos por la participación, por haber venido. Yo creo que ha sido en mi opinión, ha sido una sesión muy productiva, donde hemos aprendido muchas cosas sobre las diferentes formas de neuromodulación. No sé si ha quedado claro qué es mejor, cuándo es mejor, qué técnica va a ser. Quizá algo que ha quedado claro es que hay muchas cosas, hay mucho que investigar, que todavía no está completamente desarrollado todo y hay mucho campo de investigación, y esto es muy interesante. Hemos aprendido que se puede mejorar la memoria, que se puede mejorar la atención, que se puede aplicar en pacientes con patologías psiquiátricas, que hay cosas ya en desarrollo y aplicación, que faltan cosas como la personalización, la medicina de precisión, estas cosas, pero que bueno, es un campo muy abierto y, como decía ahora mismo Carlos, pues estamos empezando. Pero bueno, hay mucho que hacer, y esto también para toda la gente que quiera hacer investigación, pues yo creo que es un campo muy interesante. Así que muchísimas gracias, Carlos, muchísimas gracias, Carlos, porque Marco y Carlos, perdón, porque habéis hecho un grandísimo trabajo explicando cosas tan difíciles de forma tan sencilla. Y gracias a todos por venir. Muchas gracias.